All right, so today's lesson is going to be on factoring quadratics, more specifically factoring different quadratic trinomials when the a value is 1. So kind of house cleaning here in the beginning. When we talk about that a value being 1, or even what is a quadratic. So the standard form of a quadratic takes on this form. We have ax squared plus bx plus c. So this is the standard form of your quadratic trinomial. This being a quadratic because remember the highest power of an expression is the 2, right? So we can see that this is a trinomial because we have 3 terms, and the highest of the 3 terms has a squared. So we know we are dealing with a quadratic. And like I said, more specifically, we're dealing with our a value being 1. So this guy, or the coefficient of the x squared, is going to be a 1. Notice that the a value is the coefficient of x squared. The b value is the coefficient of the x, and the c value is typically the constant that you see hanging out at the end. Now, these aren't necessarily always in order. It doesn't have first, second, third label next to them. The standard form is the a is the value next to the x squared. The x is not included with it. It's the coefficient, so it's the value next to the x squared. B is next to the x, and c is the constant, or it does not have a variable next to it. Now, this is the standard form. Okay, you should have just got out of the section with being able to multiply polynomials. So when we were multiplying polynomials, a lot of your answers end up looking like that. Well, the way it came from is you had these parentheses, and these parentheses are considered your factored form. These are the factors. These are the what are multiplied to make up your standard form. Right? So the section you just got out of, you were turning factored form, or the product, into a sum. You were turning it into its standard form. What we're going to be talking about for the next couple of days is you're going to turn standard form, the sum of it all, and you're going to turn it into the factored form. You're going to turn it into its products. Okay, so very similar to what we did last class period, where we were factoring out GCFs. We were taking a sum and turning it into a product, right? We were undistributing, right? Last section, you took these parentheses and you were distributing the terms that were inside the parentheses, right? Now we are undoing all that process, and we need to find what numbers multiply those guys to get this standard form. All right. Now, I know what a lot of y'all remember from Algebra 1 and Algebra 2 is when you hear factoring, right, I think a lot of you all should remember being able to jump to the box and the diamond. Now, the reason we're starting off with the a value of 1, these are easier, these are way less work involved, but you've got to be able to identify when you are dealing with a quadratic that has an a value of 1, okay? And again, we are talking about examples like this. Notice that the coefficient of x squared here, you don't see it, right, but it's a 1 there. The diamond. Remember how these diamond problems worked? Well, on top of the diamond is the product, and it's the product of the a value times the c value. Now, when the a value is 1, obviously you're always going to be multiplying by 1 here, but I went ahead and wrote that it's a times c anyway, just because when we get factoring more complex stuff later in the chapter here, that this is what we're going to use, okay? And then below, or the bottom, is the b value, so b bottom. So remember the diamond template, the multiplication goes up, the addition goes down. All right, so this is the template that we're going to use. I've got 4 examples for us to kind of look through. There's 3 different, when we're talking about operations, there's 3 different operations that these factored forms can take on, and I'm just going to show you an example of, the 4 ways it can end up being, okay? So taking the first one really slow so we really see what's going on here. Let's identify A, B, and C. Well, the A value is 1, right? The coefficient there is a 1. The B value here is an 8. And the C value here is a 15. Okay, you don't have to do this for every single one, but just until we kind of get the hang of it, it might help you to go ahead and write those guys out. So now we need to use our diamond. Remember, on top of the diamond is A times C, so 1 times 15. And on the bottom of the diamond is an 8. So when we are factoring this A value of 1, all of our factors are going to take on our parentheses here. But one thing that we can kind of cheat and go ahead with is we know the first term in each of the parentheses is just going to be your x. All right. So now we need to figure out what goes on the side of the diamond, right? Those are the numbers that are going to go in the parentheses next to the x. What this diamond's asking you, what two numbers multiply to get us 15, but when added together get you 8? Now, some of y'all might be able to guess this a lot quicker. That's fine. It's just kind of a kind of a numbers game, a guess and check. But you can have a little bit of a structure to yourself as well. So let's start with a 15. Only a certain amount of numbers can be multiplied together to get to the 15. So that's where I'm going to start. Start with 1. Okay, so 1 times 15. 2 does not go into 15. 3 does. 3 times 5. 4 does not, but 5 does, but we're coming back up the other side. So we know we have completed, or we've shown all of the factors that go into 15. But remember, our goal was to figure out what combination of these two numbers add to get us 8, and we should be able to see, well, 3 plus 5 takes us to 8. Now, the sign to the left of them is going to stay when we are putting them in our parentheses. And there we have it. Here is the factored form of the quadratic trinomial x squared plus 8x plus 15. This is the factored form. This is what you're looking for, right? These are the factors that make up the x plus 5, or the standard form that we saw before. All right, let's do it again. Again, I'm not going to go through all of those steps again. Some of them you should be able to identify. Let's just jump into the diamond. Again, the diamond is A times C, so we've got a 27. The B value goes down. Now we have a negative 12. Well, now we've got to figure out what two numbers can multiply to get a positive, but add to get a negative, right? Well, the only way that can happen is if you're dealing with two negatives, okay? So just stuff to kind of look out for and pay attention to. Again, let's kind of take the process at hand. What two numbers multiply to get us 27? 1 times 27, 3 times 9, 4, 5, 6, 7, 8, nope, and then we're back up to a 9. So again, what combination of those guys can we add together to get us a negative 12? A 1 and 27, there's no way that could get us there. But like we talked about, the only way you can multiply two numbers to get a positive, but add them together to get a negative, is if you're dealing with two negatives. And it doesn't matter which side of the diamond these guys go on. There's kind of just a formality or a template to help you keep you organized. All right, so we have x minus 3, and then we have x minus 9. So kind of like we talked about with the GCF, you are undoing the distributive property process. You can always check your answer. If we go ahead and distribute these guys back out, you should end up with that same expression, right? This is the chapter or the section we just kind of got out of. All right, one way to double check yourself. All right, 2 more examples. Like I said, we're going to go through the different answers you can come up with, right? We just did an example of positive, positive. Then we did an example of negative, negative. All right, let's look at this next example. We have x squared plus x minus 12. Same thing going on here. We're going to draw our diamond. On top of the diamond is A times C. On top, or the bottom, the B value is a 1, right? We have a 1x, so the coefficient of 1x is a 1. All right, so what multiplies to get us negative 12, but adds to get a positive 1? Well, the only way you can multiply two numbers to get a negative is you're multiplying a positive and a negative, but the positive and negative added together gives you a positive value. So one indication that should let you know is, well, the bigger number of the two has got to have the positive, right? Because we're dealing with a positive number. All right, let's go ahead and list out our factors. I've got 1 and 12. I've got 2 and 6. I've got 3 and 4. All right, those are the factors of 12. Again, what two numbers can we add together to get a 1? 1 and 12 is not going to get there. 2 and 6 isn't going to get there. 3 and 4, but really pay attention to which one has to have the negative, right? We're dealing with a positive 1, so the positive has to be with a bigger number, meaning the 4. Right? If that were a negative 1, yeah, then the negative would flip over to be the 4 there, okay? But really pay attention to your positive negatives. That's probably the biggest misconception when we're talking about these things. I know you all should be able to find the factors. It's something that we have already done in this class. Just really pay attention to your signs. So again, when we are asked to find the factors, or it tells us to factor, this is what we're dealing with. The parentheses, x minus 3, x plus 4. This is not the answer. These are not the answer, okay? This guy here, I know dealing with freshmen for a while, that's usually the mistake that happens. We get here and we stop, okay? Make sure we are putting it in factored form. And lastly, okay, this one might look a little different. It's out of order, okay? And I wanted to show you this because maybe, you know, the ACT or the Coyote test that we need to take wants to trick you. But this is why we have a standard form. You know, I didn't tell you it was a first term, second term, third term. You know, the A, B, and C values are where they're at with the coefficient. So here, the A value is 1. The B value, remember the B value is always next to the X. Okay, well here, it's at the end, but still, the value next to the X is a -8. Remember the sign to the left is going to stay. The constant, the value that does not have a variable next to it is the C, and that looks like it's -20. Okay, so it doesn't matter what order it's in, you really just need to pay attention to the coefficients of the variables. All right, so now that we have identified it, let's go ahead and get into our X. We have A times C, which is a -20. And the B value is a -8. All right, so again, the only way you can multiply two numbers to get a negative is if one's negative, one's positive, but now when we added them together, it is a negative value. So the only way that takes shape is if the negative number is the larger value. All right, well, if you can see it, go ahead, fill it in and go. If not, we need to write out the factors of 20. I have 1 times 20, 2 times 10, 3 does not, 4 does, 4 times 5, and we're already back full circle there. All right, so our goal is to use a combination of these factors of 20 to add to get a -8. 1 and 20, there's no way. 4 and 5, there's no way. 2 and 10, right? Well, if I do 2 minus 10, right, the negative's got to be with the 10 because I'm dealing with the -8. All right, so now remember when our A value is 1, we can go ahead and formality just put in our X's, and then we have a +2 and a -10. So X plus 2, X minus 10. That is going to be our factor form, and that is what we are looking for. This is our goal for today. Pretty much just being able to find the factors of numbers, and then, well, that turns out into us being able to factor our quadratics. And again, this cool, fun, fast trick that we just learned only takes shape when we are factoring with the A value being 1.